Hey everyone, welcome back to my channel Leela Web Dev. In this video, we will learn about the another important concept in the Unix programming, the powerful concept in the Unix, that is the data streams. So what is this data streams in this Unix concept? So how this one is will be useful for us. So let's try to understand. So data streams. So we are learning about the concept of data streams. So once you understand this one, so you can able to build an amazing applications in the Unix programming. So whether you are using a Node.js or anything, whatever the language it is. So once you understand about these data streams, so you can able to develop it. So let's explore what is this Unix data streams are, why they matter, and how you can use them to create some serious applications and all this. So if you don't forget to like and subscribe and hit the bell icon before this. So let's get started about this one. So what is Unix data streams? So first of all, you need to understand what are Unix data streams. So previously we have learned about the streams concept in our Node.js, right? So the same concept only. So the same concept only. The streams are nothing but the same concept only. But Unix will be having a separate data streams. I will try to explain you that one. Every time you run an Unix executable file, so whenever you run an Unix executable file, so Unix executable file means nothing but the C program compiled and whatever the thing. So in the Unix means the C program compiled one is nothing but an Unix executable file. So whenever you run this one like a program you launch from your terminal, something like that, so Unix sets up, so the Unix means the operating system sets up 3 data streams for this process. Okay, so whenever you run an application, Unix sets up 3 data streams for that process to communicate with the outside world. So for example, let's say that you have launched the playground program. Okay, let's say that this is a playground program Unix executable file. Okay, so now whenever you launch this program, so you know the Unix will attach 3 data streams to this one, so that this playground can communicate with the outside world. Outside world means I mean to say with the outside application inside this application. So that one we will be trying to do. So these streams are like pipelines that carry data in, so that carry data in and that send the data out of your program. So that is the thing. So these data streams will be responsible, or it will be pipeline to send the data into the program and to send the output or something like that to outside the world. So that is the thing. So first data stream is the standard input. Okay, so standard input. So you'll be able to heard about this one all, standard input. Normally we will call it as an stdin. So you'll be always able to see this one, standard input. And the another one is standard output. So these are all the things you people already know about this one. And we can also call it as an stdout. And the last one is the standard error, and you can say that err. So these are the 3 data streams that will be attached to this process whenever you run the Unix executable program. Okay, or whenever you run the process, the Unix will attach these 3 data streams to the process. So these streams are the backbone how process talk to each other in the Unix. So using these data streams only, the process, whatever the process you are starting, it will communicate to each other. Think of them as an input and output channels for your program. So think of this one as an input, which takes the input for the playground, and the standard output as an output. Okay. By default, for example, let's say that when you run a program from a shell like bash. So let's say that you are running playground from a program from a shell like bash. So these streams are connected to your terminal. Okay, these streams are connected to your terminal. So how these streams are connected to your terminal? Standard input from terminal, it will go. Standard output means, so the data which the playground output is coming, it will come to the terminal, and the standard error normally terminal it will print. Okay. The first one which we will be trying to see is the standard input. So first of all, we'll try to understand about the stdin. This first of all, the standard out input or the standard in. So this is the stream normally. 1 second, I will try to explain you. This is the stream that brings the data into your process. So that means this standard in only, it will bring the data into the playground. So whenever you want to read the data in the C program means, so the data will be coming from the standard input. So typically the standard input will be always the keyboard. So whatever the keyboard, the by default the standard input, it will be always when you start a program from a terminal, the standard input will be connected to your keyboard. So whatever the data you are writing in the keyboard, automatically that input will be going into the process. Okay. So normally with the terminal we call it as a TTY. For example, if you run a command like cat in your terminal, okay, let's go to a terminal. So if you run a cat, so this is the process, and now whenever you are running and start typing the text, so this type you is feeding into the program through the standard input. Okay, standard input doesn't have to come from your, so here you need to understand that if I press here and here, no such file or directory it is seen. So here you need to understand that standard input doesn't have to come from only the keyboard. So you can redirect it to come from another process also. So that is the main thing. So here you playground, so the process, whichever the process you are having. So let's say that you are having the process, okay, the process one. So you have started a process. Let's say that you have started a process. Now the input will be coming from the keyboard. So the standard input you will be getting it from the input. Why? Because normally you will be giving it to the from the keyboard only. The input, whatever the input, you will be giving it from the this one only. For example, let's say that you can also, so let's say that process is there, you can also send the output of that process as a standard input to this process one also. So not only the keyboard, so you can redirect the process, whatever the process you are running, the output of this process you can send the input as to this one also. So this is the thing. So we will talk more about this redirection later, but just to know that standard input is the process way of receiving data from the outside world. So here the standard input is the way of receiving the data into the process from the outside world. So that is the one thing which you need to understand. The next one which I want to explain you is the standard output. So what is the standard output? Next we have the standard output, or we can say it as an stdout. This is where your process sends its output. So here the playground, whatever the thing you are doing. So in your playground C program, you will be writing the printf. These all the things is there, right? So by default, the printf, whatever printf you are trying to write it in your C program here, these all the things are nothing but a standard out. So this will be by default, it will be writing in the terminal. The default standard output, if you don't mention anything, means it will be your terminal. In return, that terminal will display the output in your monitor. That's it. For instance, when you try to use the console.log in a Node.js app, or print in the Python, or printf in the C program, you are writing to the standard out. By default, the standard out is nothing but your terminal. Okay, just like the standard in, that is the main thing. So normally, just like the standard in, so whatever the thing you are trying to see, just like the standard in, the standard out also, instead of sending it to the monitor or the terminal, so you can send it to the other process. So here I am telling you, right, the standard out for this one is some output is there, means you can send the standard output to another process also. So that is also the thing. This flexibility is what makes the Unix so powerful. So here, this is the flexibility what makes the Unix so powerful. You can take the output of one program. Okay, you can take the output of one program and pass as an input to the another program. So that is the main thing. And the input of this program is received using the standard input, and the output of the program from to the outside world will be sending it using the standard output. That's it. This is the main thing which you need to understand. Okay, so now let's say that that is the main thing. So this is all the thing. So for example, let's say that I'll try to show you a simple example. Echo hello world. If you try to write this hello world, so that means, so this is the program. Unix executable, echo is a Unix executable file, and here you are writing the data standard input, and this the data, whatever the response it is trying to give it, it will be send it to the standard output. Here the standard output is nothing but the terminal. That's it. So that is what I want to explain you. The last one which you are having is the standard error. So what is this standard error? You are already now you will be able to understand about the standard output, standard error. This is then another output stream, just like the standard out. Okay, just like the standard out, but it is typically used for things like error messages, warnings, or debug information, stuff you might not want to save as a part of your main output. By default, standard error is also connected to your terminal only. Standard error also is also connected to your terminal. So that means it will show the error message in your monitor only. The name standard error can be a bit misleading because it is not just for errors. You might use standard error for things like progress bars or logs that are critical to your program's main output. The key difference is that standard error lets you separate these messages from the main standard out data. For example, if you are getting the output in between, you are getting some warnings and errors means. So if you want to filter out these all things means, so the errors, warnings, and all those things will be sent to the standard error, and the normal output, the success output, and all those things will be sent through the standard out. So that is the main thing. So that means the key difference is that standard error lets you separate these messages from your main standard out data, which is super useful when you are redirecting the output. So that is the main thing. So now, why are data streams so powerful? So now we understood about the standard input, standard out, and also the standard error. We have understood it. Why these data streams are so powerful? So let's try to understand this one. So why you should care about these streams? So now you told me, okay, whenever you start a new program or a new process or something like that, 3 data streams will be attached by the Unix. One is you are saying standard input, and another one you are saying is the standard output, and the last one is the standard error. So why we should care about these streams? Because they give you full control as a developer. You can decide where standard input gets its data from, where standard output and standard error should go. For example, instead of sending standard out to your terminal, you can save it to a file in your disk. Okay, you can redirect standard error to a log file or even ignore it completely by sending it to the trash. Unix calls this one as /div/null, the trash thing. You can also read the standard input from a file instead of from the keyboard also, which is great for processing the large data sets. So like this, so this one, so these are very much useful. You can connect the standard out of one process. So the main thing, the main magic or the main concept which we will be doing in our upcoming videos is the standard the standard out. So here the standard out of one process, we can connect it to the standard input of the another process. This is called as piping. Okay, the standard out of one process, we will be connecting it to the standard input of another process, and lets you chain multiple programs together to create a complex workflows. For example, one program might extract the frames from a video, and its studio and its standard output can feed those frames into another program that process images. These possibilities are endless. Okay, so that is the main thing. So now streams as the data pipeline. So I have told you about the pipeline, right? Piping. So let's dive deeper into this idea of chaining process. Unix philosophy is all about building small specialized programs that do one thing really well and then combining them using the data streams. For example, let's say that you could have a program that's great at reading files, and you have another that awesome at transforming the text, like making it uppercase, and another that is perfect for finding the patterns. So by piping those standard output and standard in together, you create a pipeline where each program handles a specific task. You understood this one? So you are having a something like a program, so which is great at reading files, let's say, and that after reading the files, so one program is there which can transform the data that has read, and another one you are having another one, so which you can convert it or finding patterns. Okay, so finding the patterns means filtering the data. So like this, so this one is written in Node.js, this one is written in the C program, this one is written in the .NET, let's assume. So now Node.js, whatever the reading files and everything is finished, the content will be sent as a standard out, and here the C program will receive the data as a standard input, and it will transform the data whatever you do it, and the data will be sent as a standard out to this for this .NET as a standard input, and this one will send a standard output. Here by default standard output will be a file or a terminal or anything, whatever it may be. So like this. So this approach works with any programming language, Node.js, Python, C, Java, you name it, whatever it is. And the best part, you can do this both in code and directly in your terminal using a simple operator called the pipe, which is the symbol pipe. Okay, in bash you can run ls pipe grep txt to list files and filter for ones ending in .txt. Super simple, right? So let's try to see. I will try to show you. So that is the main thing. If you are working with the streams in the code and bash, so in the code and bash also you can work with the streams. For example, if you are writing a program, you can read from the standard input and write to the standard output or standard error using functions like console.log in Node.js or print in the Python. You can also open files or network connection to redirect the streams programmatically. So Unix makes it ridiculously easy to redirect streams using operators. For example, let's say that this one, so greater than. So we can use this greater than for the standard output. So if you want to mention the standard output other than this terminal means, so you can use this one. So for example, let's say that in your terminal, let's clear this off. So I am using the echo hello. So now I am not mentioning any standard output. By default, the standard output will be the terminal only. So it is displaying the data. But instead of this one, I want to save this response, whatever the output it is coming in a file. So then I can use it like this. The output, the standard output greater than will be representing to save the standard output to a file. So here I can write something like output.txt. Now whatever the output you are getting it will be saved in the output.txt. So here you can check it like this. See the same hello, it has been saved in the output.txt file. So now that one is a file. We can also use pipe. So we also have another one that is nothing but pipe to pipe the standard output to another programs to a standard input. So let's say that we are having an ls. So if I am trying to, so this is the output we are getting, and now using the ls and the output we are sending it as an input to the another program that is nothing but grep. I want to get only the txt files. So if I try to write like this means, so here I am able to get only the txt file. So like this you can use it. And if you want to have means, so the errors and all those things, if you want to means, you can use the to greater than. So that means whatever the standard errors you are giving, for example, let's say that I'm using cat file.txt, let's assume. So no such file or this is a standard error. So if you want to get this one means, so then you can use, if I try to use like this output.txt, then you still the output is coming. Why? Because here we are not getting the standard output, we are getting the standard error. So for this one, what you can do, so the standard errors can go into the to greater than, finish. So it will be saved in the output.txt file. So the output will be saved again. Because streams are designed to handle data as a continuous flow, you can process huge amounts of data like gigabytes or even terabytes without running into memory issues. It's all about streaming zeros and ones, whether it is a text, binary file or anything else. So that is all about the concept. So if you want to practice some things, you can practice saving output to a file, chaining the process, network communication, ignoring the standard error. You can send it to the trash like /dev/null. So these are all the things you can experiment it so that you can able to understand it. So that's it guys about the standard input, standard output and also the standard error. So I hope that you have a pretty good understanding about this one. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.